Now, like I said yesterday, what we're doing this week is a review what you did in geometry. Okay, the right triangle trig you learned there. About the book, you're going to get an online book at some point. I don't know when. When you get the book, you only have an online access to it. You also need an online homework. Pretty much the same system they use at Lone Star. And so that's coming. We're just not there yet. So until that happens, you'll be getting paper copies. If you look at these terms, these are the three that you learned in geometry: sine, cosine, and tangent. I mean, maybe you heard of cosine and secant and cotangent, but probably not. So these are basic three. The main thing I want to focus on here is the fact that these are basic trig functions. What you do with the trig functions, you give it an angle, and it gives you an answer. Okay, that's what a normal trig function does. That's what these all do. Whereas the inverses are the opposite. You give them the answer, it gives you back the angle. You should at least have that basic understanding of the relationship between them. And then we're really talking about trig functions. Here, the function, you give it an angle, like I said, as an input. It gives you an answer as an output. We also describe them as trig ratios. In fact, that's how we write the definitions. Here, go and write down SOHCAHTOA. That's how we usually memorize this. Now, sine, then, what does it mean is sine is defined as the ratio of opposite over hypotenuse. So put that for that definition. And then cosine is ca, that's adjacent over hypotenuse. And then toa for tangent means opposite over adjacent. Now, before we go on to the other three, the new ones, we can talk about what this means. And because what I'm saying is, when I say opposite or adjacent, you say, well, opposite to what? If you look at our picture, first of all, we're talking about a right triangle, and a right triangle has two acute angles. And so the angles, whichever of the acute angles you're talking about, and it's labeled here, but I'm saying that's the angle we're talking about. So when we say opposite, we mean opposite that angle. And by the way, on a right triangle, the hypotenuse, the longest side is called the hypotenuse. The other two sides are called the legs, right? And so if you want to find, so when we say opposite and adjacent, we mean the leg opposite the angle, the leg adjacent to the angle. Or in other words, when I talk about an angle is a shape formed by two sides, two rays, technically. So I'm saying those sides are the sides that form the angle. So which side is opposite the angle? The other side. That's how you identify the opposite leg, okay? And then these legs that form the angle, we say they're adjacent to the angle. So there's really two sides adjacent to that angle. But one of them is called the hypotenuse, right? So I'm saying when I say adjacent, I don't mean the hypotenuse. I mean the leg that's adjacent to it. Now, so I'm saying that's what all this means. One more thing that always throws people off, that struggle with it when they first see this in geometry, is the fact that we take these triangles and we flip them around. And so if I have a triangle that's oriented like this, which is the opposite side? The top, the right, or the bottom? So, see what I'm saying? And I can take that and flip it, rotate it, and you have to be able to tell which is opposite, which is adjacent. Okay? Now, so that's our definitions. Basically, now before I get back to these, I want to go back and talk about what the point is to all this. So let me go all the way back and talk about the word trigonometry. It is the measure of trigons. What do you suppose a trigon is? A triangle. A pentagon, the Greeks, gon means angle, so they didn't call it a five-sided shape, they called it a five-angled shape. That's what pentagon means. Hexagon is a six-angled shape. So they would call a triangle a trigon. It means triangle. And so this is the measure of triangles. That's what we're doing. That's what trigonometry is. The reason it's important is because you get into engineering, anything where you really need strength, like a radio antenna, a tower, it's formed from triangles because it's strong. You won't bend, or it won't slump at least. I mean, you could break it maybe, but unlike you go down the road, sometimes you see an old shack, right? And usually that's formed out of rectangles, which when they lose their shape, they slump over and become parallelograms. Triangles don't do that, okay? So that's one reason they're important. The other thing is, basically, if you ever deal with anything that rotates, there's a lot of things that rotate, wheels, gears, they all involve trigonometry, okay? Hold on. Thank you. Okay, thank you. And so I'm saying that's what trigonometry is. It's simply the study of triangles and the measure of triangles. Now, just look at this. I want to kind of give you a feel for where it came from. So on this triangle, you have three triangles nested together. They're all similar triangles, similar right triangles. And I'll just do the sine ratio first. So if I want to do sine, definition is opposite over hypotenuse. Let's look at the biggest triangle. Here's the angle. What's the side, the length of the side opposite the angle on the biggest triangle? Well, the 9, right? If you want the biggest. And we're doing over the hypotenuse. What's the hypotenuse of the biggest triangle? So that's what sine equals. What does that simplify to be? 3/5, right? Okay, fine. Let's do the middle triangle. It's still opposite over hypotenuse. The opposite side is 6 over 10. The hypotenuse is 10. Isn't that also 3/5? And if you look at the smallest triangle, you do opposite over hypotenuse, you also get 3/5. In fact, if you did any triangle similar to this one that has that same angle, sine of that angle is always going to be 3/5. And the Greeks realized that. I think it was the Greeks at first. I know they did this. I don't know if anyone did it before them. But they named it. Because it's always the same ratio, they gave it a name. They called it sine. Same thing applies to cosine and tangent. If you do the ratio of adjacent over hypotenuse, it's going to be the same as well. We'll just do that real quick. If you do the biggest, what's the length of the adjacent side to the angle? So you get 12 over 15 that time, which simplifies to be what? Divide by 3, you get 4 and 5, right? And in the middle one, you get 8/10. And then you get 4/5, and so that's what I'm saying. They saw these ratios are always constant, so they named them. And what that means then is you can basically solve for the angle, which we'll do. You can basically solve triangles. Now, you've learned 3 ratios, the names of these 3 basic ratios. There's actually 6 ratios you could create by just setting up the ratios of the sides on a triangle. And so the other 3 are simply the reciprocals of these 3. So the reciprocal sign is called cosecant. So write that down. Cosecant is simply hypotenuse over opposite. Just take your 3 definitions you know and flip them over. You have the new definitions. So the reciprocal of cosine is called secant, and so it's hypotenuse over adjacent. And then the reciprocal of tangent is cotangent, and that's adjacent over opposite. So I really want you to memorize them this way. You know the basic 3, and know that these are reciprocals to those, and that that's how they're related. One thing that throws people is the fact that it's just inconvenient maybe that cosine, the reciprocal of cosine, is not called cosecant. It isn't, and there's a reason why it's not, but it isn't. So I guess realize that, and just it doesn't work that way. So it doesn't work like you suppose. The reciprocal of cosine is just called secant. You memorize that. If you just know that one, well then the other one must be cosecant. So I'm saying you need to memorize this ASAP. All right, ready? Here, just write down, draw the picture, and then we're just going to find all the trig values of the trig functions for that picture. In other words, I'm not going to give you time to write down the text for the question. We'll do sine first. The hypotenuse, of course, is the 65. How long is the opposite side? And so sine is 33 over 65. Because once again, here's the angle, that's the opposite side. The 56 is adjacent, so cosine is adjacent over hypotenuse, so there's that. And what's the value for tangent? The definition is opposite over adjacent, so over 56. One thing to note is that tangent is the one that does not involve the hypotenuse. Okay. And then the others, you just do the reciprocals. So cosecant is reciprocal sine. Secant is reciprocal cosine. So they both have hypotenuse on top. And then tangent is reciprocal tangent. If you look at the picture, it's adjacent over opposite. But usually I just write tangent down and just flip it. Okay? All right, so write this down. And this time I'll let you write down everything. Now, if you're given a sign, I would still write it down. And we can do sine and cosecant right now, because cosecant is just reciprocal, so it's 3. But to do the rest, like to find cosine, we need more. Here, look, we need to put this in the picture. They gave us sine. Sine is opposite of our hypotenuse, right? But that means the 1 is opposite the angle. The 3 is the hypotenuse in our picture. So go in your picture, put the 3, put the hypotenuse, and then where does the 1 go? On the left or on the bottom? Okay? Now, for the rest of these, we need this side, this adjacent side. How do you find it? Pythagorean theorem. If you know two sides in a right triangle, to find the third, you do Pythagorean theorem. So 1 squared plus x squared equals 3 squared. And I put x. If you want to put a different letter, I don't care. Look, 3 squared is 9. That's 1. So subtract, you get 8. You can sure that work if you want to, but you don't have to. Okay? And then take square root. So the missing side is square root of 8. Which simplifies to be what? And you really should just be able to do that in your head. It is 2 square root of 2. I'm going to show you a couple ways to get there, though, okay? First of all, this is literally the easiest simplifying radicals problem you can do. You can just realize square root of 8 can be written as square root of 4 times square root of 2, and square root of 4 is 2, so that's where the answer comes from. Or, here's this method, and this method works on every problem, even the harder ones. So you take your number, whatever it is, and you break it down. You can show the work various ways. I like this way of showing the work. I'm just breaking it down into prime factors. So what I get is a prime factorization. Then watch this. What this means is my radical can be written as square root of 2 times square root of 2 times square root of 2. So this is what this gives me. But what's square root of 2 times square root of 2? 2. And then this part doesn't have a partner, so it stays a radical. And that's the other way to simplify. And like I said, this works always. Okay, no matter how hard the problem is. You break it down, look for pairs of factors. Okay? All right, let's go back and finish the problem now. So cosine is adjacent over hypotenuse. So that's the 2 radical 2 over 3. Yes? Write that down for that one. So what do you want to do next? Go and do secant or go on to tangent? Okay, let's do secant. Now, it gets a little trickier. We're going to do the reciprocal of this. I'll just put that here. Except you can't leave it like that because you can't have a radical in the denominator. I said your denominator should always be nice, positive whole numbers. So to fix it, you multiply by square root of 2, top and bottom. Because what is square root of 2 times square root of 2? 2. So the denominator becomes 4, which is good. That's what we want. So this becomes 4. The numerator is just 3 radical 2. And there you go. That's how you should write that answer. Now listen. What I want you to do is you really want to see both the unsimplified answer, because you can see that the reciprocal is there, right? But then it also equals this. So realize secant equals this and this. They're the same thing. This is just a simplified form. All right, next one, tangent. That's opposite over adjacent. So here you get 1 over, I'm going to simplify this again. I'm going to put this here. And then I can put the simplified answer right there. You do the same thing. You multiply by square root of 2, top and bottom, to fix the denominator. The denominator ends up being 4 again. And the numerator is just square root of 2. So that's that simple. Okay? Now watch this. For cotangent. Cotangent is just reciprocal. The hard way would be actually take that final answer and flip it, but if you do that, you get a radical in the denominator, right? So don't do that. Use the original. If you flip that, you get a nice problem with the radical in the numerator. In other words, the answer for cotangent is just 2 radical 2 over 1, which is just that. So I'm saying you could have taken this and flipped it, but then you have to fix it. And if you do all that work, you'll end up with the same thing we did here. But that would be harder. But you could actually just look at the picture and use the definition. Cotangent's adjacent over opposite. So you're doing adjacent over opposite. And just get it that way. Okay? You try this one. And don't write all the words this time. Just write down the value for tangent. You might even say it that way, like given tangent, so you know what your starting point was. But then find all the rest. And you don't have to arrange them this way, but I think it's helpful. Just keep it the same arrangement. Here we're trying to find the angle. And so first you have to figure out what kind of trig function you're using. It's sine because it's opposite over hypotenuse. So you write sine of the angle, sine of theta, equals opposite over hypotenuse. But then to solve that, you do like we said here, you do the inverse. You do inverse of that value. So here, write down, to find theta, you're going to do inverse sine of that value. Go and type it in. Actually, before you type it in, everyone hit mode on your calculator. And make sure you're in degree mode, not radian mode. Next week I'll explain radians too, but this week we're in degrees. So once you get in degree mode, go back to the main screen and type in inverse sine, do second sine, and tell me what you get. Someone tell me what you got for an answer. What was it before you rounded? Okay. And it did. The directions did say the nearest degree, so yes, 50 degrees is what you should have gotten. Did everyone get that? You got your calculator to produce that answer? And then, here. We'll do one more real quick. Just draw the picture. And frankly, if you're struggling with the calculator, once I'm done with this example, I'll show you, okay? What kind of equation do we set up this time? Sine, cosine, or tangent? Tangent, because it's opposite or adjacent. Basically, this problem does not involve the hypotenuse, which means it must be a tangent problem. And so tangent equals opposite or adjacent, so 11 goes over the 7. And then same thing. To find the angle, you're going to do inverse tangent of that value. Before you type it in, listen, this is not an isosceles right triangle, obviously, but that means these are not both 45 degrees, which means one's going to be bigger than 45, one's less than 45. What do we expect to get here? Something bigger or less than 45? Bigger because we're finding the angle opposite the bigger leg, right? So type it in, and you should get something bigger than 45, like I said. 57.5, and so give me two decimal places. Okay, I just want to make sure. So yeah, 58 degrees. I asked for that because, watch, if it had been 57.49, that would have rounded down to 57, actually, right? People mess that up sometimes. They kind of round to the nearest tenth and then round up more. So anyway, all right, that's it. Let me stop. Save.